ठीक है. So last time we had done the second law of motion. We had discussed the uh, at different cases of second law of motion. That is F is equals to ma, F is equals to v dm by dt, and when both are variable. Okay, so we saw one of the questions. Okay, regarding the second case. Okay, first case we are going to use regularly. Okay, so I am not going to do a question on that. But on the third case, okay, that when neither the mass is constant nor the velocity is constant. Okay, neither the mass nor the velocity is constant. So in that case, what happens? Okay, how to solve a question in that case? We will see an example for that. So let's do a question regarding that. Yeah. Okay, so this is the question that now what is happening that your rocket is accelerating from some velocity to some other different velocity, and at the same time its mass is also decreasing from 50 tons to 10 tons. So its mass is also changing. Okay, in the same interval its velocity is also changing. Okay, so if such a thing is happening, is the screen visible to everybody? Yes. uh, ठीक है. So must be some network issue. Just wait for a minute. It must be frozen or what. Something must have happened. Okay, just wait. है ना. ठीक है. है ना. So this is the question that we have a rocket. Okay, as it is increasing its speed, its mass is also decreasing. Okay, that is logical. That is what happens. Okay, in practical situations, that as the rocket goes up, its velocity keep on increasing, but slowly as the fuel is burning, okay, its mass is decreasing rapidly. Okay, a lot of mass, a lot of fuel is burned by the time it reaches the orbit. Okay, so this is what is happening, that your mass and velocity both are constantly changing. So in this situation, okay, how to solve the problem? Okay, you have to still find the force. Okay, you have to still find the force. So when the mass and velocity both are changing, okay, when the mass and velocity both are changing, so just keep the force to their basic definition, that is F is equals to dp by dt. Okay, just keep it on the basics. Okay, that F is equals to dp by dt. Acha. Now since they have given you some time interval, okay, they are not asking you the instantaneous values. Okay, since they are not asking you the instantaneous values, what we can do is we can calculate the F delta p by delta t. Okay, delta p by delta t. है. If you want, okay, you must be trying to use this formula m dv by dt plus v dm by dt. Okay, okay. In this formula, what is the issue? That we don't have a unique value of m. Okay, here they want a unique value of m. Delta v by delta t is no problem. Okay, we can find that. Delta m by delta t also we can find that. But what about the values of m and v? Okay, you don't have a unique value for m and v. ठीक है, so remember this formula, ठीक है, this formula which we have derived is used for calculating instantaneous forces, instantaneous values, instantaneous values. ठीक है, if you have been given, ठीक है, the function of mass with respect to time and function of velocity with respect to time, ठीक है, then use this formula. ठीक है, this is for instantaneous values, this is for equations you can say. ठीक है, whenever you have equations, है ना, your mass in terms of equation and velocity in terms of equation of time, ठीक है, then use this formula. Otherwise better to stick with your basic definition, that is dp by dt, delta p by delta t. ठीक है, so what you can write delta p by delta t here, p final minus p initial upon delta t. ठीक है, delta t is 20 seconds, है ना. अच्छा, let's talk about p final. ठीक है, p final will be m final v final, simple. ठीक है, final mass into final velocity, final mass is 10 tons, तो 10 into 10 raised to power 3 in kgs. ठीक है, 10 tons is 10 raised to power 4 kgs into velocity is how much, velocity is 200, velocity is 200. And p initial, if you are talking about p initial will be m initial v initial. So initial mass was 50 tons, so 50 into 10 raised to power 3 into initial velocity was 100. ठीक है, so replace these values over here, replace these values over here. Again, when you put final minus in, get some answer in negative. ठीक है, again you will get some answer in negative. ठीक है, again the logic is same. ठीक है, why such a thing is happening, because the air is coming out. ठीक है, it is because of Newton's third law you can say. ठीक है, which we will do later after this, that when the air rushes out, ठीक है, the reaction force is applied in the opposite direction. ठीक है, so that is why negative sign is there. ठीक है, because of that Newton's third law you can say. ठीक है, so that is a different matter. We are interested with the magnitude only. ठीक है, they have asked you the thrust force, that means they are asking you only the magnitude. ठीक है, they don't want you to find the direction, so they won't ask such a thing. ठीक है, hope it is clear. Any doubts, anybody? ठीक है ना, so these are the three cases of Newton's second law which you must keep in mind. ठीक है, you have to keep these three cases of second law in mind, because any one of the cases can be to you. ठीक है, any one of the cases can be asked to you. अच्छा, next we can do, what we have to do is impulse. ठीक है, this is second law. ठीक है, second law is done. ठीक है, you have done all the cases which can be used in second law. The first case, ठीक है, you know, first case will be very frequently used in the later parts of this chapter. ठीक है, where we will be dealing with tension and all. ठीक है, so there we will use only F is equals to m. So keep it for that only. ठीक है, don't need to solve over here. ठीक है, next is your impulse. ठीक है, which you should know is your impulse. ठीक है, it is, you can say a derivation of second law. ठीक है, it is an outcome of second law you can say. ठीक है, so what is impulse? Impulse is a very large force, very large force applied for a very short time. Very large force applied for a, not a very large force but a large force. Okay, you can see it like that also. A large force applied for a very short time. Like suppose you throw a ball, okay, on the ground. Okay, you throw a ball on the ground. What happens? It collides with the ground, and within an instant, okay, within an instant, it returns back. It bounces back. Okay, that time of collision, you can say the time of contact is very small. Okay, So in that very small instant of contact, very small time for contact, the ground must have applied some force on the ball. Okay, it is logical. If it would not have applied some force on the ball would have broken the ground. Okay, so to resist that temptation, to resist that breaking, okay, what did the ground do? It applied a force in the opposite direction. It pushed the ball upward, okay, by applying a force in the upward direction, hence creating a change in the momentum. Okay, so in that very small amount of time, the ground created such a large force that the ball's momentum became in opposite direction. That's force, that particular force is called as impulse. Okay, we denote it by I. Okay, not always. Okay, but for this case we can denote it by I. Okay, so this is the definition of impulse. A large force for a very short time, like collision is there, bouncing of a ball is there. Okay, for a very short time, if you are applying forces, then the force is called as impulse. है ना? Mathematically, how we, अच्छा again, ठीक है. Suppose let's take an example. ठीक है, let me draw. Suppose I have thrown a ball with a speed v. ठीक है, ball I have thrown like this. ठीक है, what will happen, it will collide, and in that you can say in that very instant, ठीक है, suppose if the collision is elastic, ठीक है, so in that very instant, in that you can say in milliseconds time, ठीक है, the ball will start returning with the same velocity. ठीक है, ball will start returning with the same velocity. Now what happened here, the initial momentum of the ball was mv I cap. ठीक है, initial momentum of the ball was mv I cap. After the collision, the final momentum of the ball became what, mv minus I cap. mv minus I cap. ठीक है, so you can see here there is some change in momentum. ठीक है, you can see that there is some change in momentum, है ना. If there is a change in momentum, there must be a force being applied. ठीक है, there must be a force being applied there, because what we write, force is written as dp by dt, है ना. So wherever there is a dp means what, change in momentum. Wherever there is a change in momentum, there will be a force connected to it. ठीक है, so here since the force is changing, है ना, here since the momentum is changing, there must be a force between the wall and the ball. ठीक है, now that particular force which the wall is applying on the ball is for a very short interval, very short, we cannot measure that time. ठीक है, it is very short, it is in milliseconds, microsecond. ठीक है, since it is in a very short time, what we say is that it is impulse, it is not a force. ठीक है, force should have some time. ठीक है, it takes time to show effect. ठीक है, so force needs time, it needs dt. ठीक है, but if the time is very short, we are not able to measure it, that force will be called as impulse. ठीक है, we know there is some force, but we are calling it with a different name, that is impulse. That's it. ठीक है, so impulse is basically force only. ठीक है, but for a very short time, like that you can understand. ठीक है, now is it clear? है ना, ठीक है, अच्छा, so हाँ, ठीक. Now see, this is the the theoretical definition of impulse. What about the mathematical formula of impulse? ठीक है, how to calculate the impulse? ठीक है, I know that there is a force, I know that it is applied for a very short time, but what is the magnitude? How much is the magnitude? How much is the impulse being applied by the wall? ठीक है, for that there is a mathematical relation for impulse, that is integration of f dot dt, force for a very short interval of time. ठीक है, force into very short interval of time, that is impulse. ठीक है, f can impulse f dot. ठीक है, this is how impulse is defined. this is how impulse is defined. Integration of f dt. है ना? Now from the basics of integration, we know that integration f dt also represents area under the ft graph. Area under the ft graph. Okay. So I am just telling you this because these are the methods in which you will be able to calculate impulse. In these manners, the questions will be asked. We will see the questions, you will understand how to use it. Okay, but for now, it is area under the FT graph. है ना? अच्छा, also just let's see, F force can be written as dp by dt. Force can be written as dp by dt. Okay, and it is multiplied with dt, so you can say that dt is getting cancelled. So this becomes integration dp. Okay, if you integrate dp, it will come out to be delta p, change in momentum. Okay, because there will be some initial momentum, there will be some final momentum as the limits. So when you replace those limits, okay, it will become p final minus p initial. As and when it becomes p final minus p initial, it becomes change in momentum. Okay, so there are two methods to calculate impulse. One is integration f dt. Okay, if you have the ft graph, calculate the area, you will have your impulse. And second is to calculate the change in momentum, delta p. Okay, so these are the two ways, these are the two methods to calculate impulse at any point or at any situation, at any instant. Okay, so let's see an example. Okay, you will be able to understand it better in that way. Okay, you have to remember this only. Okay, these are all derivations and all, not at all important. Okay, final thing is which you have to remember is this, that impulse is calculated in these two manners. One is the area under ft graph, and the other is change in momentum. Okay, so let's see question. Okay, so here you have to find the impulse by the force. Okay, impulse by force in time 0.04 seconds first, and in time 0.02 seconds. Okay, say that what is the impulse applied by the situation, what is the impulse applied by the force in interval of 0 to 0.2 and 0 to 0.04 seconds. Okay, in these two intervals you have to find the impulse. So simple. Okay, we know that the formula of impulse is integration f dot dt. Integration f dot dt is basically representing area under the ft graph. It is basically representing area under the ft graph. So if it is area under the ft graph, so simple. In the first case, okay, in the first case, if you see, let's calculate the second case first. Okay, time is 0.02 seconds. Okay, that will be easier to calculate because it is only a triangle. Okay, if you see the area under the ft graph till 0.02 seconds is a triangle. Okay, it is a triangle. So the area can be written as half into base into height. So half into base is how much? Base is, you can see, 0.02. This is the base, 0.02. Okay, into height is this you can see is equal to 50. So into 50. Okay, so this comes out to be 0.5 Newton meter, Newton second, sorry, Newton second. Okay, so this is the impulse. Okay, an impulse of 0.5 Newton second is being applied in this situation. Okay, now what about the first case? What about the first case? Okay, now the area, okay, the area will be this total area, okay, from 0 to 0.04. Okay, so already you have calculated the triangle. Now you just have to add the new area of the rectangle also. That's it. That's it. ठीक है. So area, total area in the second case, for first case, ठीक है, when the time is 0.04 seconds, ठीक है, it will become 0.5, that is for the triangle, plus area of the rectangle. Area of the rectangle is 0.02, yes, into 50. ठीक है, 0.02 into 50. Length is this, that is 0.02, you can see, and now 0.04 to 0.02 into breadth, that is 50. ठीक है, so this comes out to be 0.5 plus 0.221, 1 plus 0.5, that is 1.5 Newton seconds. ठीक है, is clear. है ना. So this is how you calculate impulse when graph is given to you. ठीक है, whenever the graph is given to you, just calculate the area. ठीक है, ft graph will be given in most of the cases. Ft graph will be given, so just calculate the area. As and when you calculate the area, you will have your answer. Yes, yes, I got that. That is why you are getting one. ठीक है, no problem. है ना. अच्छा, the second method, ठीक है, the second method to calculate this, if someone wants to write this, you can write it. Okay, nothing to write. It is a simple question of you can say integration also, you can say. Okay, this you must have done many times in motion in a straight line. Okay. Yes, yes, you could have used the formula of trapezium also. No, not an issue. Okay, what I need is I need the total area from 0 to 0.04. Okay, in any manner which you can calculate, you can calculate. You can give me the answer. Okay, method is not important to me. What I need is the area. However you calculate is correct, no problem. Okay, the answer should be matching. That's it. Okay, so trapezium, you can see it as a trapezium also. If it is a trapezium, so you can use the formula of trapezium also. Okay. So this was impulse. And now one method of impulse. Let's see another. Okay, suppose I have a wall. Okay, so you have to find the impulse imparted by ball on the ball. Okay, the ball is thrown towards the wall with a velocity v. Okay, it is moving in a straight line. Okay, you don't have to worry about the gravity and all. Okay, it is moving in a straight line. Okay, it collides with wall and bounces back again. Okay, in this direction. Okay, this direction is also theta. This is also, you can say, is given in the question. So that means there is elastic collision. Okay, they could have written in the question that the ball is showing elastic collision, like that only. Okay, instead of showing angles, they could have written that the ball is showing elastic collision. Then what will be the situation? So this is the situation, and then what will be the impulse? So you have to calculate the impulse now. Okay, so how should we calculate the impulse? What should be the method? Okay, just tell me the steps, that what should I do one after the other. Yeah, you just calculate, take 2 minutes and calculate it yourself. Good. Okay, that the first sentence is take components. That is very good. Okay, if you are taking the components, okay, you are on the right track. Just solve it yourself. Okay, it is a very easy question. Okay, you can calculate it. Just tell me what should be the impulse, final result for the impulse over here. Obvious, you can say m1 v1 is equals to how can you say m1 v1 is equals to m2 v2? How can you apply conservation of momentum? nahi. See, even elastic collision, when you're talking about elastic collision, the elastic collisions condition will be applicable only in the vertical direction, that is direction, in the horizontal direction, that is direction perpendicular to the wall. Okay, when you write elastic collision na, if you remember elastic collision, okay, elastic collision is applied only in this direction, not in this direction. Okay, momentum is conserved only in the perpendicular direction, not in the horizontal direction. Okay, so that is a different matter. Don't try to just mix two things. Okay, the momentum in collision is a different thing. Okay, in collision we will see that. Okay, don't try to just complicate simple matters. And this is a very simple thing. Yes, 2 mv sine theta. Very good. Everybody is getting almost this. Okay, minus 2 mv sine theta is the direction. Okay, because it will be in this direction. So that is why you might be getting minus 2 mv sine theta. But if I'm talking about that magnitude, okay, if I'm talking about the magnitude, it is 2 mv sine theta. Okay, very easy. Okay, you have to do nothing. You just have to take the components. Okay, you just have to take the components. So see, this is theta. Okay, so this angle will also be theta. So this will be v cos theta. This will be v sine theta. Similarly, for the final condition, okay, if this is theta, this will be theta, v cos theta and v sine theta. So you can see here that the momentum in y direction is same. Okay, momentum in y direction is not changing. Earlier, okay, before collision, the momentum in this direction is how much? mv cos theta, and after collision also the momentum in this direction is mv cos theta. So there is no change in momentum in y direction. Okay, in the direction parallel to the wall. Okay, but in direction perpendicular to the wall, you can see that in this direction the momentum was mv sine theta. Now it has become minus mv sine theta, that is in the opposite direction. So if you calculate the change in momentum, okay, now here you can see that you cannot integrate area, you cannot calculate integration of f dot dt because there is no force, there is no time. Okay, but there is momentum. Since there is momentum, impulse can be written as delta p, that is p final minus p initial. Okay, p final minus p initial. If we are just talking about the magnitude, we can apply a mod sign. Okay, so you can see that the change in momentum is 2 mv sine theta. It is 2 mv sine theta. Okay, it is minus mv sine theta minus mv sine theta. Okay, so minus 2 mv sine theta, but we are talking about the magnitude, so it becomes 2 mv sine theta. Okay, so this is the final impulse imparted by the wall on the ball. Okay, this is the amount of, you can say, force required to change the direction of your ball. Okay, by this much angle, whatever the situation is happening, by theta angle. Okay, so this is the case of impulse. Okay, this is how you use impulse. It is a very small thing. Okay, if you want, just remember the two basic things. Okay, these two things. No more complications can be created in this. This is the maximum variation can create. Okay, impulse can create. So don't worry about impulse that much. Okay, it is a very small topic. Just a small topic between second law and third law. Okay. Acha. Now let's move on to third law. Okay, let's move on to third law. NLM 3. Okay, also called as action reaction law. Action reaction law. Okay. So statement, everybody knows the statement that for a given action, there is an equal and opposite reaction. There is an equal and opposite reaction. Okay, so this is the statement, very simple statement. Everybody knows this, that if you apply a force on some object, the other object applies a force on you with the same magnitude but in opposite direction. So important thing here to notice is that you can just take a note. Okay, it can be asked in a theoretical form that action and reaction forces, action and reaction forces acts on different bodies, different bodies or object, whatever. Okay, whatever is the situation. Like suppose uh, suppose this is the block and someone is applying a force like this. Okay, someone externally is applying a force like this. Okay, in this direction. So what will happen is that this block, let's not take it like this, better to understand. Okay, that the block is kept on the ground. Okay, block is kept on the ground, and what is happening is that the block has some weight. Okay, block has its weight. Okay, there is a gravitational force acting on the block. So the block is trying to do what? It wants to go down. Okay, so uh, if it wants to go down, but it is unable to go down. Why? Because there is a ground in between. Okay, the ground is there in between. So what happens is the block applies a force on the ground. Okay, if you see the ground, okay, there is a force like this applied on the ground. Okay, this is the whole surface of the block. Okay, this whole surface of the block is applying a force on the ground. Okay, so that it can go down. But 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 the ground is resisting it. Okay, the ground is resisting it. How? By applying the same amount of force in the upward direction on the block. Okay, it is applying the same upward force on the block. If I draw the block will be having a force like this. Okay, so these are action reaction pairs. Okay, this is action. Action is on the reaction is on the block. Okay, the reaction is on the block. Okay, so you have to be careful. Okay, you have to remember that action reaction pairs are not acting on the same body. They are always acting on different objects, different bodies. So here you can see that action is on what? Action is ground. Okay, and action is acting on the ground, whereas reaction is acting on the block. Reaction is acting on the block. Okay, so this is a point. This is an important point which you have to take care about action reaction pairs. Okay, action reaction forces, you can say. Okay, so this is action reaction Newton's third law. Okay, there are examples of Newton's third law. Okay, that we are able to walk because of Newton's third law. Okay, when you push the ground backward, okay, the ground pushes you in forward direction. That is why you move forward. Okay, that forward force is friction only. Okay, the other way to represent that forward reaction is friction only. Okay, and suppose the second example is the rocket. Okay, what happens is when the fuel, okay, what it does, it pushes the air downwards. Okay, so action is acting on the air in the downward direction. So what does the air do? The air applies a force on the rocket in the upward direction. So that is why it is propelled upwards. Okay, so these are few of the examples of action reaction pair. Okay, these are the few examples of action reaction pair. Okay, so these are theoretical things. You already know these. Okay, you must have studied them in 11th. Okay, so we don't have to worry about it. Okay, no one is going to ask you in detail what are the examples of action reaction pair. Nobody asks this in NEET. Okay, NEET is not interested in that. Ah, okay, so this is Newton's third law. Okay, now let's move on to the mechanics part of your chapter. That is common forces in NLM, common forces in Newton's laws of motion, or common forces in mechanics. Common forces in mechanics. Yes, any doubts, anybody? ठीक है, हाँ ठीक है। अच्छा अच्छा अच्छा, वेट वेट वेट, one thing we forgot, that is conservation of momentum. ठीक है, conservation of momentum we did not see. So let's see conservation of momentum. Conservation momentum. ठीक है, conservation of momentum is another important conservation law. ठीक है, you know that there are three or four conservation laws. ठीक है, one is conservation of momentum, conservation of angular momentum, conservation of mass, and conservation of energy. ठीक है, these are the most not mass, sorry, conservation of charge and conservation of energy. ठीक है, these are the four important conservation laws which are very essential for physics. Okay, if these laws won't have been there, the physics could not have been developed. Okay, so one of them is conservation of momentum. Okay, so what is conservation of momentum? You know that. Okay, whenever the F external net external force on the system, net external force on the system is equal to zero. Whenever the net external force on the system is zero, this implies okay, let's write it here. This implies that dp by dt of the system, okay, rate of change of momentum of the system is zero. Now think it in the form of differentiation. When will the differentiation of some term become zero? When it is constant. Okay, so since here we are differentiating momentum, if the momentum becomes a constant value, then its differentiation will be zero. Simple. Okay, so therefore if you solve this further, okay, if you integrate it like, okay, if you integrate it, okay, you get that your system momentum of the system becomes equal to constant. Okay, your momentum of the system becomes equal to constant. That means your initial momentum is equal to the final momentum. This is called as conservation of momentum. Okay, that your momentum is constant. This is called as conservation of momentum. Okay, so you have to take care if and only if the net external force on the system is zero. Net external force on the system is zero. Okay, it is very important. So how we can see that? Let's see through an example. Okay, let's see a question. Simple. Okay, so this is the situation that you have two masses. Okay, suppose let's take the value of m1 as 5 kg, m2 as 10 kg, u1 as 2 meters per second, and u2 as 1 meters per second. U2 as also 2 meters per second. Okay. What happens is that both the blocks are moving towards each other. Okay, both the masses are moving towards each other with equal velocities, that is 2 meters per second and 2 meters per second. So what happens is that they collide, and after the collision, what happens is that they start to move together. Okay, they stick together to each other, and if they stick together to each other, they will be moving with the same velocity. You have to find what is this common velocity. Okay, this everything will be written in statement form. Okay, it will be written in word format. Okay, so I guess you can convert that word problem into this diagram. Okay, once you can convert it into this diagram, 50% of your question is solved. Okay, because you are able to see the motion and all. Okay, 50% of the question is already done. Okay, now how to solve this? Okay, now see here. when they were colliding, ठीक है, before collision there was no external force, ठीक है, yes, most probably 2 by 3, ठीक है, I also have to calculate, I just made up the values, so I have not calculated it, but still, and what I was saying, that before collision, ठीक है, before collision you can see that there is no external force acting on the system. Before collision there is no external force acting on the system, ठीक है, that is clear, there is no doubt in it, ठीक है. Also after collision, ठीक है, after collision also there is no external force, after collision also there is no external force, but 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 during collision there was force, but is it external or is it internal, that is what you have to decide, ठीक है, that is what you have to decide, ठीक है. All of you are calculating it because you know that momentum is conserved over here, but important thing is how is the momentum conserved, why is the momentum conserved, ठीक है. So why is the momentum conserved? See, I am saying that when they will be colliding, this is m1, this is m2, ठीक है, what will be happening is that m1 will be applying a force on m2 and m2 will be applying a force on m1, ठीक है, because when you are colliding two objects, the one object will apply a force in the other on the other object, and the other object will apply a force on the first object. So if they are applying force on each other, what will happen is that these force will cancel each other out, ठीक है, Newton's third law, ठीक है, it is action and reaction pair, ठीक है, these are action reaction pair, so they will cancel out each other. So when I see them as a whole system, when I combine them and see them as a whole system, the net force on the system is zero, net external force on the system is zero, ठीक है, that is why conservation of momentum can be applied over here, conservation of momentum can be applied over here. So conservation of momentum, if you want to apply, it will be P initial is equals to P final, P initial is equals to P final. So let's write P initial first, ठीक है, initial momentum, ठीक है, let's take this direction as positive, if you taking the right direction as positive, it will be m1 u1 minus m2 u2, ठीक है, this will be the initial momentum, and final momentum will be what, ठीक है, you can see that it will be m1 plus m2 into v, ठीक है, it will be m1 plus m2 into v, they are also in the positive direction, so m1 plus m2 into v. So just replace it over here, m1 u1 minus m2 u2 is equals to m1 plus m2 into v. So v comes out to be m1, how much is m1? 5 into 2 minus, upon m1 plus m2 is 15. So 10 minus 20 by 15, 10 by 15 minus 10 by 15, 2 by 3. Minus 2 by 3 meters per second is the combined velocity, combined speed of the blocks. Okay, so minus 2 by 3 means what? Negative sign represents just the direction, simple. So earlier what I did was I considered the direction to be in the positive direction. Well, sorry, velocity to be in the positive direction, but actually they will be moving with a speed of 2 by 3 meters per second in the opposite direction. That's it. This is the significance of negative sign. Okay, this is what negative sign signifies. Okay, so 2 by 3 is the answer. है ना? अच्छा. Always remember, write the momentum in terms of vector only. Okay, never take only the magnitudes. If you take only the magnitudes, your answer will definitely. Okay, so someone I don't know so who, someone had written 2 also. And so most probably you have not considered the the direction. Okay, you must have done m1 u1 plus m2 u2. Okay, so that is wrong. Direction also you have to consider. Okay, if you neglect the direction, then it will be wrong. Okay, so this is conservation of momentum. You all know the basics of conservation of momentum. Okay, so now let's move further. That is common forces in mechanics. Now see, we are going to discuss here all the basic fundamental forces which you use. Okay, you already know tension, weight, okay, friction, and spring force, normal. Okay, you already know all of the forces. Okay, so I won't go into details. Okay, we will only just see the important points and move forward. But see here, all the questions cannot be discussed here. Okay, you know that NLM is a very wide range. Okay, NLM has a very wide range, so various kinds of questions can be created. Okay, just by the basics, if you remember the basics, okay, you can solve those questions easily. Okay, you can solve those questions easily, but I am telling you this, that all types of questions cannot be discussed by me in the class. Okay, that is up to you. If you are solving questions, if you are solving problems, okay, you will have doubts. Okay, you will have to ask those doubts to me later on after class. Okay, I cannot discuss all of the types of questions in the class. Okay, I will try to cover as much as possible, but all of the types cannot be covered. Okay, so you to see the different types of variation, okay, you have to solve questions on your own. Module is there, solve the module. Okay, if you have any other book also, okay, you can solve from that book also and ask me the doubts. Okay, I'm not recommending to use books now. Okay, time is not there, time is of essence here. So try to first solve the complete module first. Okay, all the questions, okay, it is present there in the module. Okay, if you solve in even that many questions now, all of your doubts will be clear. Okay, there won't be any doubts left in NLM. Okay, so let's move first. First is your weight. Okay, WIGST, weight. And at W it is represented by W or mg. Okay, W is basically your mg only. Okay, W is equals to mg, or the gravitational force. है ना? अच्छा, if it is the gravitational force, then it is first one another point which you can add in here is it is always directed downwards. Okay, it is always directed downwards. It is always in the down direction. Okay, towards the earth, because we always consider the earth to be at the bottom. Okay, it is not never in the upper part. Okay, upper up direction, and it is always in the down direction. So that's it. Weight is only this much. It is a constant force. Okay, it is constant. You have to remember. Okay, mg does not change. Okay, we won't be changing the mass, and in most of the questions we won't be changing the values of the mass. Okay, second is normal reaction. Normal reaction, okay, denoted by N. So about normal reaction, you have to understand that it is a reaction force. It is a reaction force. That means there must be some action to create reaction. Okay, there must be some action to create reaction. And a basic idea of how the actions will be created is, first of all, okay, it is also called as, it is a contact force. It is a contact force. Why contact force? Because if there is no contact, there won't be any action. Okay, whenever you are applying a force, you need contact with the block or object, hai na? So that is why if you create action, reaction will be created, and that will be called as normal reaction. Okay, so contact is required. So it is a contact force. Whenever there will be a contact, there will be a reaction force. Okay. Acha, second is that it is directed towards the object from the contact surface. Okay, you have to remember this also, that suppose I have kept a block like this. Okay, I have kept the block like this on the ground. Now this is the contact surface, this surface is my contact surface, and this is the center of the block, you can say. Okay, so from the contact surface, the normal reaction is always directed towards the block, that is towards the center of the block. Okay, it is always directed from the contact surface towards the block. Okay, so this is the normal reaction on the block. Okay, I'm not talking about on the ground. If we would have been talking on the ground also, no. So this is the contact surface towards the ground. Okay, it will always be towards the object. Okay, whatever you are studying. Okay, suppose you are studying the block, then towards the block. If you are studying the ground, then towards the ground. Depends on the situation. Okay, depends on which object you are studying. Okay, which object is in your frame of reference. Okay, so this is how you can remember normal reaction. Okay, basics, you know, the basic idea of the normal reaction is known to you. Okay. Acha, in this also a few variations can be created. Okay, let's see a question. Okay, this is diagram 1, this is diagram 2. Now just tell me what is the number of normal reactions in both of the cases. Okay, in the first diagram, how many normal reaction is acting on the block? Okay, and in the second one also, how many normal reaction is acting on the block? Just tell me. Okay, let's write this as N1 and N2. So what should be the value of N1? That is number of normal reaction in first case, and N2 is the normal number of normal reactions in the second case. Just tell me what are those, or what should be the number of normal reactions as per you in the first case and second case. Yes. Very simple question. Very simple question. One and two. Else. Two. Two for both. Two in both. Two and three. Okay. So the options which I am getting is, let's say A option 1 and 2, B option 2 and 2, C option 2 and 3. Okay. These are the variations which I am getting. Anybody else? 0 and 2 is also there. Achha, D option. D option. Let's create a space for D option also. D option 0 and 2. Any more options? Anybody? Okay. Now see, the answer for this is 1 and 2. Okay, answer for this is 1 and 2. Yes. And now why 1 and 2? Try to understand. Okay. In the first case, if you draw the mass M in the first case, okay, you can see that it is in contact on both the surfaces. Okay, it is contact in both the surfaces. I am not denying that it is not in contact. Okay, don't go for the diagram. It is in contact in both the surfaces in both the cases. Okay, it is on the vertical also, horizontal also. There is contact. But when you see that when it is applying a mg force in the downward direction, it is creating some action in the ground. Okay, it is creating some action for the ground. That is why the ground is creating a normal reaction in the upward direction. Okay, it is creating a normal reaction in the opposite direction. But is there any action? Is there any action for the horizontal wall? Sorry, vertical wall. Okay, no, it is just in contact with it. It is not creating any force on this wall. So if there is no action, how can there be any? In the second case, when you are applying a force, externally, then there is a action on this vertical wall. Okay, then there is a reaction on this vertical wall. Okay, it is being applied some force. Hence, it will create a normal reaction in the opposite direction on the block. So in the second case, if I draw the diagram, in the second case, my diagram will be okay, mg in the downward direction. So one normal balancing this. Okay, and a force in this direction will be balanced by a normal reaction in this direction. This can be written as n1, n2. So in the second case, there are two normal reactions, but in the first case, you can see there is only one normal reaction. Okay, so that is why you have to understand, है only an action can create a normal reaction, not contact. Contact does not create normal reaction. That is why the name is normal reaction. Okay, not normal force. Why we are not using normal force every time? Okay, it is called normal reaction for a reason. Okay, if there is action, then only there will be a normal reaction. Okay, so in the first case there is only one normal, in the second case there are two normals. Okay, is it clear? ठीक है, I got that. ठीक है, mg is weight ना, mg is weight. mg cannot be considered as normal reaction ना, mg is the w, it is a different kind of force. ठीक है, अच्छा, hope everybody got this. ठीक है, because this is another thing where they can create tricky questions. ठीक है, this is another point where they can create tricky questions. ठीक है, so this was about normal reaction. ठीक है, the basics of normal reaction you know. ठीक है, that we will see that later on. Okay, let's talk about tension first. Okay, third is your tension force. Okay, third is your tension force. So tension force, okay, first of all, it is always created inside a rope. Okay, it is always inside the string or rope, whatever is there, string, rope, or whatever is there. Okay, so it is always inside a string. So if there is a string, if there is a rope, then tension will be there in the system. Okay, otherwise it won't be there. Okay, the second thing is that if string is massless, okay, if the string is massless and inextensible, if the string is massless and inextensible, tension is same throughout the string. Okay. So first of all, what is meant by massless? Massless means that the mass is very less. Mass is negligible compared to other masses. So suppose there is a block of 10 kg and you are hanging it by a rope of mass 0.01 gram. Okay, so that mass of the string is very, very, very less compared to 10 kgs. So such a string will be called as a massless string. For us, massless means there is no mass. Khatam. Okay, for us, if the string is ideal, the string is massless, that means the mass of the string is 0. That's it. Okay. And so if the string is massless, if the string is ideal, then the tension at all points on that string, okay, the tension at all points on that string will be same. Okay, if the tension is coming out to be 10 Newton in the string, then along its complete length, okay, the tension will be same. Okay. Acha. The direction of tension is along the string, but away from the object, Okay, like what I'm trying to say, that suppose I have a mass hanging from a string like this. Okay, I have a mass hanging from the string like this. So this is the point of contact where the tension should be created. Okay, where the tension is being seen. Okay, you can say. So if I draw the free body diagram, okay, if I draw the free body diagram, everybody knows what is free body diagram, I guess. Okay, so first of all, the tension is along the string. Okay, so either the tension is like this or the tension is like this. Okay, so tension is along the string, that is in the vertical direction. Okay, so first point is done, that it is along the string. Second is away from the object. Away from the object means the upper direction. Okay, it is not towards the object, it is away from the object. So this is correct, this is wrong. Okay, tension can never be towards the object, it will always be away from the object. Okay, so these are the few points which you have to take care about while writing tension, while using tension in your free body diagram. Tension is a internal force. Okay, it is not a action reaction force. Okay, you can say it is action also. Okay, it is action also. No, it means we cannot comment on action reaction. It is you can say a reaction force. Okay, what you are doing here is, see, if the string would have been at its natural length, okay, if there is no force being applied on it, there is no tension created in the string. Okay, but since here what is happening, the mass wants to go down. So what it is doing, it is pulling the string. It wants the string to increase its length. So the string is opposing that, that intention of the mass, you can say. Okay, the mass wants to elongate the string. So to stop that elongation, to prevent it elongating, okay, the tension, the string is creating a tension in the opposite direction. Okay, it wants to get elongated in this direction, but since it applies the tension in this direction, it stops the elongation. Okay, so that is why strings length do not change, but springs length can vary. Okay, they can change. And so this is the source of you can say the tension, that it wants to prevent itself from elongate. Okay, you can compress it definitely. You, if you apply force on string like this, it will get compressed. Okay, so it cannot prevent compression, but it can definitely prevent elongation. Okay, so strings can slack, springs do not slack. Okay, springs do not slack, because if you compress it, it will apply a force in the opposite direction. You all know this. Okay, this is the basic. Okay, so this is a few important points about tension. Okay, acha. Uh, after this there is friction, but before that let's do some questions. Okay, we have 20 minutes on our hand, so let's do a few questions. Let's start with basic only. Okay, no problem. Okay, this is the question, that you have to find the acceleration of each of the individual blocks, and also the normal reaction between 10 kg and 5 kg and 5 kg and 25 kg. Okay, because they are in contact, so there will be a normal reaction between them. So what is that value of normal reaction? just calculate yourself. Okay, the very easy question. Okay, just write yourself and tell me what should be the answer. Yes, anybody getting the answer? At least you must have found out the acceleration. Just write what should be the acceleration. टू पॉइंट टू यार इतना सुंदर नंबर दिए हैं मैंने. द आंसर शुड बी अ ब्यूटीफुल आंसर यार. 10, 100 and 150. 10 is correct. 100 and 150, just check once again. I am getting 300 and something. Okay, acceleration is correct. Normal reactions are not correct. Not getting any answers. $350. First or second? Whatever, first or neither first nor second is 350. अच्छा. अच्छा तो 25 लिखा हुआ है यार. Acceleration is 10 meters per second, no doubt in that. 300. Nice, nice, nice. One of the answers is 300. Okay, one of the normal reaction is 300. I will solve, yaar. Just have patience. Okay, you are not able to find your mistakes. ठीक है. चलो. Let's see. First of all, let's talk about the motion of the three blocks. Okay, first of all, let's talk about the motion of the three blocks. When I'm pushing the three blocks, okay, when I'm pushing the three blocks, what is happening that whatever displacement this 10 kg block will show, whatever displacement the 10 kg block will show, the same displacement will be shown by the 5 kg and the same displacement will be shown by the 25 kg. Okay, if they are having the same displacements, है ना, and if you differentiate those displacements, they will have the same velocities also. They will have the same velocities also. Now, if you again differentiate this velocities also, okay, if you differentiate these velocities also, they will have the same acceleration. Okay, so it is you can say that it is known to us that acceleration of all the three blocks will be same. Okay, now how to calculate that acceleration? If they are having the same acceleration, 2 is 250. Good, 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 good. 250 and 300. That's it. 300 and 250 is the answer. Okay, F1 is 300, F2 is 250. Good. Now, where was I? If we want to calculate the acceleration, so it is simple. It is simple. Okay. Since they are moving together, what you can do is you can combine the three blocks. You can combine the three blocks. That is 10, 5, and 25. If you combine it, it will become a 40 kg block. It will become a 40 kg block on which a 400 Newton of horizontal force is acting. Okay, in vertical direction also, ठीक है, बस no comments है ना, no comments. ठीक है, क्लास में नहीं, फालतू मस्ती नहीं. चलो, in vertical direction there will be forces. Okay, in vertical direction there will be forces, but we are not interested in that. Okay, you can calculate 40 mg as the weight. Okay, total weight, and there will be a normal reaction, but that is of no interest to us. Why? Because it is in the vertical direction. Okay, the blocks are moving in the horizontal direction, so better to stay in the horizontal direction only. Okay, do not disturb vertical direction until and unless necessary. Okay, acha. Now if we are talking about the horizontal direction, okay, in the horizontal direction it has some acceleration a. Okay, whatever is the acceleration of 10 kg, 5 kg, and 25 kg, the same acceleration will be there for the 45 kg also, for 40 kg also. Okay, because they are combined and made together, na? Okay, they are combined from these three only. Then how can the acceleration change? Acceleration cannot change. So if you talk about the horizontal direction, we can write Fx is equals to max. Okay, on the horizontal direction. Okay, the net force on the horizontal direction is equals to mass into acceleration of the horizontal direction from the Newton's second law. Okay, second law we wrote that whenever the mass is constant, we can apply F is equals to ma. So mass is constant over here, mass is conserved over here. So we can apply F is equals to ma. Acha, F, how much is the force? Okay, for that, first of all, you need the positive direction. Okay, first of all, you need the positive direction. So always remember the direction of acceleration is considered as positive direction. Okay, if the acceleration is in this direction, the right hand direction will be your positive direction. So what you can write, the force can be written as plus 400 because there is only one force acting on it. So plus 400. Okay, in the right hand direction it is, so plus 400. This is equal to m. M is 40. Ax, acceleration in x direction is how much it is? A, in the positive direction only. So plus a. Okay, so from here you can solve and get the value of acceleration as 10 meters per second square. Okay, you are getting the answer in positive direction only, positive value only. That means the direction of acceleration which you have assumed is correct. Okay, the direction of acceleration which you have assumed is correct. In that direction only acceleration will be there. Acha. So this was acceleration, that is the first part is done. Now what we need the normal reactions. Okay, when you were studying the three blocks combined, okay, you cannot see the normal reaction. Okay, you cannot see the normal reaction in 40 kg. How can you see the normal reaction in 40 kg? Okay, normal reaction, if you want to see normal reaction, you have to study the blocks individually. Okay, you have to study the blocks individually. How? Let's see. Let's take out 10 kg block and study it. Just take out the 10 kg block and let's study that in the horizontal direction, not in the vertical direction. Okay, in the horizontal direction. So in the horizontal direction, you can see it has some acceleration a. Okay, we have already calculated the magnitude of a, so we can use it over here. Okay. Also, our force of 400 Newton is acting on the 10 kg block. So I have drawn this force also. It is asked to calculate the acceleration of individual blocks, but whatever is the acceleration of individual blocks is the same acceleration the combined block has. Okay, so answer of your individual acceleration is also 10. Actually, the same acceleration 40 kg will also have. So their accelerations are equal, you can say. Okay, so this will also have 10 meters per second square. This is also 10. This also 10. Yes. Acha. Now let's talk about 10 kg. So we had drawn for 400 Newton. Okay, we have drawn 400 Newton force. But now you can see that the 10 kg block. Okay, the 10 kg block. Yes, okay. The 10 kg block will be applying some force on the 5 kg block also. Okay, the 10 kg block will be applying a force on the 5 kg block. It will be pushing the 5 kg block. So the 5 kg block will do what? It will apply a normal reaction in the opposite direction. The 5 kg block will apply a normal reaction in the opposite direction. If you are not getting it by that manner, okay, you can understand by the points which I had written for normal, that normal reaction is always directed towards the object. Okay, normal reaction is also always directed towards the object. It is directed towards the object means what? It is directed like this. This is the normal reaction N1. Okay, between 10 kg and 5 kg, the normal force on the 10 kg block can be seen like this in the towards the object direction. Okay. Acha. Now what you can do? Now you can apply F is equals to ma. Fx is equals to max. Again, your acceleration direction will be considered as positive. Your direction of acceleration will be considered as positive. So you can see here that 400 is in the positive direction. So plus 400. Your N1 is in the negative direction. So minus N1. Okay, because it is in the negative direction. This will comprise of your net force in the x direction, Fx. Okay, this will be equal to m. M is how much? 10. M is 10 into acceleration. Acceleration we have already calculated it as 10. So this is 10. Okay, so 400 minus n1 is equals to 10 into 10. So from here you can calculate the value of n1 as 300 newtons. This is the value of normal reaction between 10 kg and 5 kg. Okay. Acha. Now what about the second normal reaction, that is between 5 kg and 25 kg? Okay. For that you can do what? You can study the 5 kg block. Okay, we can study the 5 kg block. How? Let's see. Bring out the 5 kg block. Okay, draw the free body diagram of 5 kg block. So it has acceleration a. It has the same acceleration a, that is 10 meters per second square. Okay, and there is a normal reaction on the left hand side. Okay, there is a normal reaction on the left hand side because of 10 kg. How much is that normal reaction? That is N1 only. Okay, it is the action. Okay, it is the action. This is the reaction. This is the action. So these are two action reaction pairs. Okay, so when we are studying the 5 kg block, it behaves like the action in opposite direction, same magnitude. Okay, so its magnitude will be how much? It will be 300 Newton. Again, the 5 kg block will be applying a normal, will be applying a force on 25 kg. So that 25 kg will be creating a reaction in the opposite direction, normal reaction in the opposite direction. Or simply you can write that the normal force will be directed towards the object. That is, it will be in this direction N3. Okay, it will be in the opposite direction. So if it is in the opposite direction, simple again, Fx is equals to max. Again, the direction of acceleration is considered as positive. Okay, Fx is how much? Fx will be plus of n1. plus n1 because n1 is in the positive direction now. Okay, earlier it was n1 was representing the reaction, that is why it was in the negative direction, but now it is representing the action, so it is in the positive direction. Okay, and n3 if you see is in the negative direction, so minus n3. Sorry, should be n2. Okay, it should be n2, doesn't matter. Okay, that is just a variable representation. Minus n2. This should be equal to mass. Mass is how much? 5 kg into acceleration is how much? 10. 5 into 10. N1 was how much? 300 minus N2 is equal to 50. So if you solve here, N2 comes out to be 250 Newton. This is your answer. Final result of normal reaction between 5 kg and 25 kg. What magnitude of normal reaction is magnitude of force exerted? No. Why magnitude of force exerted is n1 minus n2, na? How are you saying magnitude of normal reaction is magnitude of force exerted? Net force exerted is n1 minus n2. Now, so that is a different thing. Okay, don't try to mix those things. Okay, Fx what we are writing is representing the net external force. Okay, it is representing the net force on the body in x direction. Okay, so don't try to mix it with normal and all. Okay, that is representing a completely different thing. Okay, so this is how you can do questions on normal reactions. Okay, okay, time is almost up. Okay, so we will stop here only. I won't do any further questions. So next class most probably sir will take, most probably. Okay, let's see. But if he does not take, then I will be only there. Then we will do questions on. Okay, now okay, your theoretical part of NLM is over. Okay, now there is only questions and questions only. Okay, there will be questions on normal, there will be questions on tension, there will be questions on normal and tension. Okay, then there will be questions on friction. Okay, then there will be combination of this. Okay, so okay, that is a different thing. Okay, so it is not a dangerous word. Okay, it is very easy. Okay, once you understand the basic. Okay, what I told you here. Okay, these steps which I have told you now, how to draw the free body diagram, how to write force and force is equals to mass into acceleration. If you keep these points in mind, if you keep these points in mind, then it will be easy to solve. Okay, it is nothing new. It will become very easy. Okay, so don't worry. Okay, Suhas is just trying to make you afraid. Okay, ignore him. Just ignore him. Okay, so we will see what kind of questions will be done. Okay, chalo then. That's it for today. है ना? Thank you. Okay, if somebody has doubts or if somebody wants to write this, you can write this. Yes, Vedant, you have written it correct, है ना? Whenever a person stands on the ground, he exerts a force on the ground. Okay, that is a force which is equal to your weight. Okay, that is a force equal to your weight, but that is a different kind of force. Okay, that is a different force. It is not the weight. Okay, so yes, force exerted by the ground is reaction. Yes. Okay, when you are standing on the ground, you exert a force on the ground. Ground exerts a force on you. That is action reaction pair. ठीक है ठीक है